So hello viewers and welcome back to another video on networking. So I hope you have got the last video where we have seen the simulation of Cisco Packet Tracer of DHCP protocol, and we have seen that how we can simulate DHCP protocol. We have observed the packet flows wherein there was a first case where we have seen that how the DHCP works if all the devices that are making the DHCP request, they are all in the same network with the server. Now in today's video what we'll do, we'll create another network. We'll use the routers and we'll put the end devices connected through router, and we'll see that how the DHCP will work, where in case we have the end devices in another network, they are who are making the DHCP request to the DHCP server which is in the another network. So that is the second case of our simulation, that we have kept the packet flows over here in this slides. So let's start the video without wasting much time. So we have this network already configured in the last video. We'll continue from here only, where in this case, so we want to simulate the different networks and devices are in the different network. So what we can do is we can take one router, and now we can take one switch and couple of end devices, right? And we can connect all this using this. We'll connect these two end devices with switch, and then we'll connect both of the switches with router. So what we'll do is as now we have configured the connections, so we have connected all the devices. So as you can see, this router will separate this entire network with this network. So this network is 192.168.10/24 as we have studied in the last simulation, and this network over here that we have just connected, which is 192.168.20/24. Now as you can see, the default gateways are over here. So for this network, this interface of a router will be a default gateway, and it is 192.168.10.1/24. And for this entire network, the interface of this router will be default gateway, and as the IP address of this is 192.168.20.1. Now as you can see, for this end devices, the DHCP server is in the same network, but for this end devices, the DHCP server is in the different network. So what we'll do is we'll configure the DHCP pool over here in the server. But before that, we'll assign the IP addresses to this router interfaces of this router. So now let's do that first. So yeah, we can go to fast Ethernet 0, and we will configure 192.168.20.1, and we'll enable this from here 192.168.10.1/24. So as you can see, fast Ethernet 0/1, it has been assigned this IP address 192.168.10.1, and fast Ethernet 0/0 has been assigned 20.1. So you can confirm from over here 0/0 and 0/1, right? And now another setting that we need to configure is from config section. We can go to global configuration mode, and from here we can go to fast Ethernet 0/0. So for this interface of a router over here, we would need to configure an DHCP relay. So for this entire network, this DHCP Discover packet will reach to this interface, since DHCP Discover packet will be a broadcast. Now router will not process the broadcast packets, but since we will configure, we need to configure the DHCP relay. And what DHCP relay will do is it will convert the broadcast packet that will be sent by devices in this network, and it will unicast the packet, DHCP Discover packet, to the server. Now for that, the DHCP Relay Agent over here will somehow need to know the IP address of the DHCP server, right? So that's why we'll configure, and we can configure that using CLI. So from fast, we need to let the interface of this interface of a router let know that the DHCP server's IP address is 192.168.10.2, and for that what we can do is we can enter IP helper address 192.168.10.2 255.255.255.0. Okay, I don't think we'll need the subnet mask. Yeah, so that's how. So for fast Ethernet 0/0, we have configured the IP helper address, and we can just exit from here. And remember, we don't need to configure the IP helper address for this interface fast Ethernet 0/1, because for this the DHCP server is in the same network. So we have configured a DHCP Relay Agent for this interface only. Now what we need to do is second step. So the second step is to configure the DHCP pool on this DHCP server. So now let's understand how to do that. So now, as you might have known from the last simulation, that we have server pool configured over here. Now what we can do is we can modify this pool name. So let's say remote pool, and we can change the parameters accordingly. So the default gateway is 20.1, which is default gateway for this network. Then the start IP is 20.2. Since the 1 is assigned to the default gateway and there is no such devices which is holding 20.2, we have 10.2 holded by the DHCP server. That's why we have kept a 10.3 starting address for our server pool. But over here we can just keep 20.2. So the subnet mask is /24, and we can keep maximum number of devices, maximum number of users, any value that you want. And now these are the settings. Yeah, that's all we need to configure, and we can click add over here. Now remember, don't click save, and we will create we'll click on add. So this will create a second pool, which is remote pool, and server pool we had from the previous sessions. So you can see we have configured the pool for this entire network. Now we can just go to simulation mode, and we can click through this PC4 config fast Ethernet, and we can click on DHCP. And now let's see how the packet flow looks like. So this is a DHCP Discover packet, as you can see, and you can observe the packet formats over here. As you can see, this is Discover packet. And now let's see what happens. So this packet is a broadcast. Now the switch, as soon as the switch receives, it will broadcast to all other interfaces. Now this machine will reject the packet, saying that there is no DHCP server running on my machine. But let's see what is router doing. So it will process and construct an ARP request. So fast Ethernet sends out an Ethernet frame, and as you can see, it is sending an ARP request to 10.2, as you can see. So right now it doesn't have a MAC address for 10.2, and since the server wants to unicast the packet, it wants the MAC address of this particular 10.2 IP address over here. And as you can see, it sends out the ARP packet. ARP is broadcasted to everyone. Everyone reject the packet because they don't have the 10.2 IP address, but the server has the 10.2 IP address, so it will reply. Now let's see outbound PDU for that. And as you can see, the MAC address, target MAC and source MAC address are both filled. Now as soon as the router will receive the packet, so the DHCP packet first time will expire because the server doesn't the router DHCP Relay Agent doesn't have any MAC address. That's why the DHCP DORA packet that was sent by this Discover packet that was sent by this machine has a timer. Now once the timer will expire, this machine will again send the Discover packet. Now let's see what happens. We have again we are again sending the Discover packet from this machine, and as you can see, the message is broadcasted. And now as you can see, this machine rejected the packet because there was no any DHCP server process running on this machine. Now let's see what router does. So let's understand the logic. So as you can see, it receives fast Ethernet 0/0 receives the frame. The frame's destination MAC address matches the receiving port MAC address, the broadcast address, or a multicast address. And the device further decapsulates the packet. And the device looks up the destination IP address in the CEF table, and it has an entry for this packet. So now it's dispatched the packet to the upper layer. And as you can see, the device decapsulates the PDU from the UDP. And as you can see, the last layer logic, it says the packet is DHCP packet. The DHCP server processed it. The DHCP server received the DHCP Discover packet, and DHCP server does not have the pool configured for the received port. It drops the packet. And now let's see what happens. The packet matches the helper criteria. So now we have configured the IP helper address command. So that was matched by the packet, and the device forward the packet to the helper address. So the device looks up at the destination IP, and it has found the entry MAC address for the destination IP address. And that's how it further sends the packet. So as you can see, the inbound packet was broadcasted, source IP and destination IP you can see. But outbound packet, as you can see, source IP is 20.1, which is the DHCP Relay Agent IP address, and destination is 10.2. Now the important fields to observe over here is the relay agent address. So as you can see, as we have studied in the packet formats, so this field will carry the first DHCP IP address of the first DHCP relay agent. So that's how it is used, and we can further see the simulation. Now this will be sent to the destination device only, because the packet was no more broadcast packet. And as you can see, it will send the ping ARP first, so we can just check. So as you can see, this was ARP packet, ARP for 20.3. Now let's see what happens. It will again send the ARP packet over here for 20.3. Now let's see what happens. None of the device has 20.3. So actually the packet timer for this ARP will expire. And let's see what is the packet that is being sent by this server. Okay, it is again an ARP packet. So now ARP packet was timed out, and the server is sending DHCP offer. As you can see, it is destined for 192.168.20.1, and these are the fields. So server is offering 20.3. Now let's see what happens at the routers. So as you can see, it is router is receiving the packet, and now everything is same. But now when we see the outbound, you focus over here, the source IP is 20.1, but the destination IP changed to broadcast, and inbound was not broadcast. So because we don't have we don't know which devices has requested the packet, and as you can see, the rest of the fields are same. So that's why now this packet is no more unicast, it is broadcast. So the switch will receive it, it is a broadcast, so it will be broadcasted. This machine will process it since the device MAC address matches, and it will send the request packet. Now request packet is broadcast from this this device will send the packet, but from router it will not be broadcast. We can again see the inbound packet. As you can see, source IP is 0 and destination IP is all ones, and there is no relay agent. But now when in outbound, we can see source IP is 20.1, destination IP is 10.2, and relay agent is 20.1. So that's how the packet fields are changed, and now this packet is a unicast packet. So it will directly goes to server, and the server will send the acknowledgement. Now let's again look at the inbound. So as you can see, this is an acknowledgement packet, and it is source is 10.2 and destination is 20.1. But when in outbound, you can see source is 20.1 and destination is broadcast. So again, this packet will be converted from unicast to broadcast. Now again switch will broadcast the packet, and this machine will receive the packet. It will get the IP address and it will assign all the details, and it will send the gratitude ARP. As you can see, gratitude ARP request. So yeah, that's I think that's it for today's video. We have seen the simulation of DHCP protocol, where we have seen that how DHCP protocol will work when in case we have the devices requesting the IP address from different network to the DHCP server who is in the different network. And we have also seen the role of DHCP Relay Agent. If you want, for the experimental purposes, you can create another router in between and see what packet formats are changed and how the packet is traveled across the different networks. That might be an assignment for you. And if you have any doubts in that, you can just ping me in the comment section of this video. And yeah, that's it for today's video. I hope you have got the idea about how DHCP works entirely. In the next video, we'll simulate entire DHCP protocol inside an NS3. So that's it for this video. We'll meet in the next one. Till then, keep learning and keep exploring.